it over.
All right. Well, welcome to our seminar today, folks. So, as Scott mentioned, we're going to be talking about workflows today. Um, Two articles. One was a very much like general thought piece kind of on workflows. The other one kind of applied it a little bit more to programming. So, I guess maybe what I'll start is with a little quick review of the two articles, and then and then I got a couple prompts for us. So let me share my screen and at least that window. All right, so the first one came from this Stimpunks um, site. I feel like it's a play on steampunks, but not quite. Um, and so this site is kind of interesting. It's kind of focused on neurodivergence and like articles are all around that kind of stuff. And this workflow thinking, what is kind of a general piece on like what is workflow thinking and how you might want to apply it. So it talks about, workflow thinking is breaking things into smaller steps and and kind of thinking about things before you actually sit down to do them. So like how might you organize your tasks to make them more efficient or to kind of get a plan before you actually start doing whatever workflow it is. A lot of workflow articles I found were actually around writing. I guess like for writers, the workflow is a thing that they talk about. I didn't know that. I thought that was kind of an interesting application of workflows. So yeah, like here they talk about an approach to writing. Here's a neurodivergence piece that it taught that was the site's kind of focused on how workflows can help kind of get rid of that like bramble of thoughts in your head when you go out to do a task and help to organize them in a way and like in a step-by-step nature that allows you to kind of tackle things in a logical, organized fashion. Mm. Oh, there's a book attached to this. So this is actually a review of a book that's linked below. And this book it's kind of interesting. I think some interesting pieces in it. It's really focused around writing, but there is like process computing in here and contemporary computing and how they use like computational tools to help them write. And while I think like a lot of this, some of it is very focused on like the written word, a lot of it definitely could be applied to how you think about how you write a program instead of, literature. It's kind of long. There's a bunch of different chapters in here, but this book is I came across and was kind of poking around in there. I thought about assigning something in that, but it was a little bit more than I wanted to get into today. So let's see where I'm at here. Yeah, I like this here. Workflow functions as a personal process rubric and kind of a lens. So the way when I like think about writing code, it's very personal. Like everyone kind of structures things their own way. There is no like right answer to like what's the workflow for a process. Like the like intricacies of like what order you do things in, sometimes it doesn't really matter, sometimes it does. It helps you kind of like take a break between steps and see like how you're doing if you're like on the right track versus like trying to write a program all at once and then seeing if the output's right and then figuring out where you screwed up along the way. It gives you that like internal rubric around along the way um to kind of like see like how am I doing? Is this step correct? And it allows you to like we haven't talked about this, but break things into unit tests because you can test each unit or each step along the way and see if it's functioning the way that you think it's supposed to. And then it gets very, meta with the metacognitive lens piece here. But again, it like for me, it helps me think about different ways of doing things. Like if I just start to write code, oftentimes for me, I like just do the first thing that pops in my head. But if I take a day or sort of think about it, I realize that maybe that first idea wasn't exactly maybe the best way to do it. And I'll often think of like a more elegant way or maybe a quicker way to do it. And so thinking about these steps in a workflow before again you write them down, I think is a really good way to kind of internalize that process and think about things in a all in a metacognitive lens. That's a new word for me. And then here again, so intertwined with technologies. That's why I really like this article, and then the kind of the concept of this of that book they were talking about, because it really blends the workflow and how you can engage with technologies. And when folks like kind of the programming, most programming paradigms break things into steps and functions and methods and classes, and so they all have ways. There's many different ways of breaking programs down into steps or into um, digestible pieces, so that you aren't looking at the entire thing at once, and that you're looking at like just one class or just one function at a time. And it really allows us to put everything in our brain at once instead of trying to like shove the whole process in your head. You can think about it bit by bit and then make sure that each one works before you go on to the next one. And so I really like the way it intertwines with technology and talks about how you can, use it to help you out. So workflow mapping, that's a thing. We could explore that some week if we were super interested in that. But this was, yeah, this was in the article to kind of give a good background on what workflow thinking was. And then I wanted to do something a little more practical, so I threw this one in there. And this is kind of like a generic way to think of how to program and the workflow for programming. So not only does again, getting a little meta, not only does your code have a workflow, but like your programming approach can also have a workflow. And I thought this one was really good. This is stuff that I often think about. And wouldn't have written down necessarily, but these are definitely things that I think about before I write code. So like think first. Mention that a couple times. Don't go, searching for the Stack Exchange or the Gemini answer to your coding problem right away. Think about it a little bit. Think about the order of the steps that you want to do. Maybe write down the steps in English or pseudocode and kind of start to organize your thoughts and think about all the steps you have to do. Whether it's in like a flow chart or like an outline, all those things are super useful ways to organize your thoughts before you get back to it. It also gives you a nice little like to-do list, a checkbox, whether you cross out the pieces of the workflow when you're done with them or check off the pieces of the outline. It helps you. For me, it like makes me feel like I'm accomplishing something. Um, Mastering the fundamentals. Yeah, like don't dive too deep into the weeds, or like in the rabbit hole for each little piece. Sometimes things are super easy, and then and it's easy. You want to master those. Um, but then some pieces it's not worth figuring out right away. Handling errors, yeah, yeah. Like think about what the actual source of the problem is instead of just trying a bunch of different things until it works. Is kind of the goal point of that one. Well, I thought this was good too. Like as you approach programming projects and the things you want to work on, spend more time on things that are going to be useful in the future. So like Noah and I just had this conversation like last week. Like we were trying to fill some gaps in a forcing data set. And instead of like trying to write the code for like just that one variable, we took a step back and said, okay, how can we write code that's going to be more useful for different variables in the future? And what kind of pieces do we need to be able to fill any gap, not just a specific one? And so we use those kind of conversations to say, well, let's write some code that's going to be useful in the future, something that we're going to come back to versus, filling this gap. And then next time we have a gap, we have to kind of start over and write from scratch because that code wasn't very flexible. I'm not going to go through all these, but I thought this was some good stuff. Oh, this is a good one. Use boring technologies. A lot of people try to go and get the latest, greatest, most, fad, you know, uh, module or library they can because everyone's using it. And then, it's changing every week because there's a new release, and then the API changes because it's not stable yet, and you have to rewrite your code. So, like, using new stuff is sometimes helpful because that's your only choice, and it might
Yeah.
be faster, more efficient. But, the tried and true things like Pandas, Matplotlib. I mean, they haven't changed in, years now. So I like this idea of keeping your tech stack to a minimum. Don't just add modules because it can do one fancy thing, because if that changes, your whole code is broken. So use boring technologies.
Bennett's got their hand up there. I mean,
Oh, good. Okay. Yeah, sure. So that's kind of a good overview. So Bennett, what you got?
Um, so quite a lot of this actually also sounds like it fits into some of the agile programming things.
Hmm.
One thing that I adapted from that, the most articulate and popular of the agile programming people are the people who wrote Ruby on Rails, and they really have it sort of tailored. Their explanations of it are tailored for web programming, where you're going from page to page. But I find that get a stack of bar napkins. When you write on a bar napkin, you don't have the same kind of writer's block that you have when you write on real paper. And if you put the name of each function on a bar napkin, you put them on a table and rearrange them and slide them around. And then I have gotten a lot of use out of writing stub functions so that I can get the flow to go by. And all the function
Yes.
actually does is say, I just ran whatever's going to happen at this step. I'm moving on to the next step, which is a real printf statement. And you can kind of figure out then how the pieces of your program are going to fit together with each other. And it's really easy also to induce errors, so that if you want to figure out what do you do if you get an error at this step, that you can do that. So between the actually using little physical pieces of paper for subroutines and error conditions and so forth, not putting it on real paper, it subconsciously reduces the amount of stress that you have on, oh God, I'm writing this down as a finished product. Somebody is going to look at it and judge me for it, even if it's just me. I am my
yeah,
own worst critic, right?
yeah.
So
I always
it's,
assume my first draft is a throwaway. I
yeah,
mean,
I
you gotta
try
be
to
you gotta be
assume it.
prepared for that.
Yeah, I try to assume it, but it's nonetheless, I still end up. So I find working with a felt pen on a stack of little 4x4 bar napkins to be really helpful, because then it actually looks stupid, but it's really useful.
It is. Yeah, it's similar to the Post-it. I've seen the same concept on a whiteboard and Post-its.
Yeah.
You just shove them around until
Yep.
find the connections are short and common, so they sort of fall into groups of related utilities and functions.
Yep. Yep. And then that whole idea of sort of whiteboarding in code,
Yeah.
where you write dummy functions and then you can figure out, okay, does this really need to be a function? Should this be a class? How is this
Yeah.
going to work if an error occurs? And you can throw all that in there before you get to the hard part about manipulating the data and figuring out how the data is going to cause you errors.
Yeah. Yeah. And I think it's exactly what all of these this flow thing seems to be along that line. I mean, it's similar. I like to start in the middle at some level of coarseness, saying this is kind of the root function I want, and work out from there. It's like, oh, I'm going to go down into detail to get the ifs and buts, and I'm going to go up to get the API calls.
But
Um, so
I've I've also found it sometimes a little helpful. The there it was fashionable for a while to have people writing code by writing tests. You write your unit tests, and
yeah,
if you write the test first, right, then the code sort of falls out naturally. But figuring out what you need to actually test can be really hard. And so that's also something I find, that sort of mocking it up so that it doesn't really do much, and then trying to think through the steps that we'll go through
yep,
will help you figure out what you actually need to test. Um, as an exercise, and um, we always used to do this around that beverage that typically comes in pitchers that we may not be able to talk about anymore because of other things, late at night in a pizza parlor. But we used to have fun with friends sitting around going, okay, we're working on this thing. What could we give it as input that would mess it up? And just literally have a brainstorm of how many different ways could we think of to make this function have an error?
Yep.
And then we,
Sometimes you bring in folks who have no idea what you've written just to say,
right,
what would you do to it? Without
right,
knowing what's under the covers,
right.
take a whack at it.
I had a really good example because we wrote a program, we thought it was super cool, and then we had somebody who had a non US English keyboard.
Mm.
And we discovered that our program did not deal so well with extended Unicode.
Yep.
So that led then to a whole bunch of other tests. So yeah, you're right. I mean, that's exactly right. When you bring in people who bring in unexpected variations, you're going to learn a lot. Anyway, that was all my thing. Sorry, Pat. I didn't mean to
Oh, that's
take
great.
that down a big rat hole.
I love so I'm glad someone else does stub functions. I do those all the time where like I'm I'm in a flow and I'm coding stuff up, I'm in a workflow and I like, oh, I don't want to deal with that now. I'm just gonna write a function that does that and put a print statement in there that this does this now and like keep going and
Yeah.
then like come back to it later.
Set a
Again,
default
it just
value or something, but not the real calculated value.
yeah, it just really helps like break that writer's block and get you and keep you going. And then like Bennett said, sometimes then you go back and you decide whether you actually need to write a function for it, or whether it's like a couple lines of code that you can just put in, or class, so you just a couple lines of code you can put in your script. Any other comments that people had, just like initial thoughts on
I'll
this?
throw a dusty tome on the table. Having done this for a little while, back in my very earliest IBM days, they had something called hypo, the hierarchical input output charting. It's kind of like a flow chart, but it's higher level. It's like block diagramming your whole program out. You basically list all your inputs, you list all your outputs, basically diagram the connections between them. Once again, the sort of like, you want to shorten the line lengths. So it's like if this needs a whole bunch of input from this other thing over there, then maybe you should maybe you should work them close together, not have them be, at opposite ends of the flow. So just another graphical technique of doing the similar thing, block diagramming. And I still do a lot of it. I don't use the little plastic template anymore with a pencil, but I do a lot of whiteboarding with blocks and interconnects. If you find that you got a snarled mess, you probably didn't do a good job organizing it yet.
Any other thoughts, initial thoughts about this? Any things you saw in like the prayer mindset that really struck you that thinks things that you do?
I
So,
will.
oh, go ahead, Noah.
I say I was definitely gonna say like thinking through a problem. That's something I've learned, especially this past year. Is like thinking through a problem before just trying to whack at it with your coding hammer would definitely help you out in the long term, like save you time. And same with like sort of investing in maybe like, oh, am I doing a repetitive task over and over again? Maybe I should code this up to a function so I can just pull out this handy function whenever I'm doing this in the future. And that those investments of time have really like helped me out in my work. And I think that's also part of like having that workflow mindset of thinking about or just sort of being like self-aware of like what the projects you're doing are and like what you're trying to figure out and keep your program's like goal or the goal of the project you're working on in mind at all times when you're without getting too lost in the weeds or the thicket of coding.
Yeah, Bennett, go ahead.
So two things. One, a very, very, very long time ago, this obscure computer scientist named Don Knuth came up with this idea of literate programming, which essentially means that you write the documentation for the code as you write the code, and they're in the same file.
Heresy.
Yeah, and as a practice, and also because I've worked in a lot of research labs where people are not very computer literate, I I like to write comments first and then put the actual code in after. It's kind of like an outline almost. The other thing that I do is I try to keep in mind that the comments in the file are not there for me while I'm coding it, because I've got this all right in the front of my head and it's right there and I know what's going on and all the context is fresh. These comments should be, I think they should be written for an undergraduate who's been working on this project for 3 weeks, who's been asked to fix this code because now it's broken.
Yep. If you ever step in front of a bus, somebody better be able to figure it out.
Right. And we tend to write the comments more as reminders to our current state of mind rather than to our future self who has forgotten everything. And so I like to see a lot of comments. I will sometimes organize them so that there's a big explanatory block of comments at the top, and then have much more concise comments that are sort of in line as we go through. But especially in Python, if you're writing a lot of Python, people come to Python and they're really new and they don't necessarily understand what, like Python built in. There are a lot of Pythonic structures that just look like, a rat ran
Dense.
across your keyboard.
Scott loves
Yeah.
it when I do those.
Yeah.
I understand the elegance, but
Yeah. And these days, computers and computer time is cheap enough that I would rather not waste the reader's time and have my code be a little bit inefficient than make it so that somebody actually had to spend a month before they could figure out what my code did.
yeah.
Yeah,
There's definitely a balance in there someplace.
Yeah, I drop
Elegance
URLs in mine all the
versus
time because,
obviousness.
often I'm coding and, to some like algorithm or some like method for converting from like relative humidity to standard humidity, or like some, equation that gets popped in there to do some kind of conversion. And I'll go back later, I'm like, where did this equation come from? And so I often drop URLs in there and say, this is what I'm doing, what I'm looking at while I'm writing this. This is where these thoughts are coming from. Because like Bennett said, I write it mostly to my future self. Because when you're doing like multiple projects, and then you go back to something that you're working on 6 months ago, you have no idea where that idea came from. So, I love the idea of writing the comments first, because then again, your outline is kind of like in your code, and then you can just follow along your outline, and then the lines of code kind of come from that.
I will say, I think we've several folks on this team that I've seen the same technique of just saying, I know this is just kind of a stopgap and it's not the best solution, a to-do. It's like sometimes somebody should make this a better thing. Just a pointer saying that, it got us around this corner, but it's a rough spot and it's good for this data, but it's probably not general. So, those sorts of be nice to your future self. Sometimes I have to apologize to my future self as I'm writing something, saying, I know this isn't good, but it needs to be done today. But back to workflows. If you chart this stuff out and you know where these things are, it's also good. You can mark it on your workflow diagram or on your, your high level diagram saying, this is a spot that needs, bolstering or refinement. It's good enough for today's data, but I know it's not going to handle, holes in my data, or I know it's not going to handle out of range data, or whatever it is you got done today, but is not the ultimate solution. So those are the things I also like to mark on a sort of system diagram saying, come back here and make this better.
So as researchers, a lot of folks on this call, I got kind of coders second, researchers first. What do you think can you think of another, there's other benefits to building these workflows. So when you're putting together your publication for your research, these workflows are often a really good diagram for your publication, right? I can't tell you how many times my workflows, like oftentimes, I'll print it up, but oftentimes my workflows end up in my publication because you publishing code in like a little call out box is kind of a lot, and you don't know like if the person reading it's going to be, you know, fluent in that language. So a lot of times when you have like when you're developing like a new process or like a new protocol, you know, you put those, you know, lab protocols in your publication, and computational workflows belong in there as well. So it's not really, so I don't want, I think it's, you know, I think sometimes people think of it as like a waste of time because you're never going to use it again, but you use it again, it shows up in slides, and it's a nice figure for your publications.
It's also good. I mean, a lot of journals now make it possible for you to publish supplementary materials.
Yeah.
And it doesn't, maybe even it doesn't happen as often as it should, but you know, every once in a while you might get surprised by some person that you've never heard of in Singapore writing and saying, hey, I want to replicate your work. And it's nice to have this workflow that you can just give them and say, this is the version of whatever I used. These are the steps that I took. This is the data that I did it on. Make this work on your computer, and then you're all set to modify it to work on the data that you wanted to try it on. That's what makes, I mean, that's a lot of what makes scientific progress possible is that. That's also, right, part of that whole reproducibility thing. Someone else should be able to come along and take your code and put it on their computer and take your data and get the same answer. And it is a lot of work, but in some fields, it's becoming almost required now. So
Yeah, the bonus article that I put in the email was really talking about the benefits in terms of programming of using workflows, and reproducibility was a big one in there. And I 100% agree. Like whether you want to swap out the data or swap out like a bit of the workflow for a different algorithm, and then being able to run that workflow again, like all of these things are extremely much easier if you've kind of thought about this in a workflow mindset versus a kind of flow of consciousness script that is hard to like kind of modify and change for other applications. So,
One,
yeah, go ahead, Scott.
I was gonna say, so from kind of workflows and research, and maybe especially like more exploratory research, I often have like no clue kind of where I'm going with an analysis when I start like working with a data set. I don't know if I'm building a model, just doing like summary or but I I have tried more on recent projects to sort of like if that's the case, like still kind of like find like where the sort of like data processing or like data pre-processing kind of ends, and like where I then load that into like kind of the exploratory tools, and like that data like processing and setting up as a workflow that is really easy to rerun and like pull in an additional variable or like change the format can be really time saving. Even if you don't like then, you know, even if you never like make the sort of like modeling part a full kind of like workflow, that data processing and setting that up in a workflow can be really helpful.
Kind of the antithesis of using a Jupyter notebook where you have, you know, 742 cells, 50 of them are actually what you want. The other ones were just poking around and they're in the wrong order. And I mean, the notebooks I generate are often not very well portable to the ultimate code. It's a messy process, and I see that as almost the counter argument for workflows is that sort of helter-skelter, try it until that line of code works method that Jupyter does. Sort of works against the flow.
I've always thought of Jupyter Notebooks as a publishing tool. It's not a working tool.
Yeah, once again, you've got to scrub all of the try it's out.
Yeah, and make sure that you started a fresh kernel and all of the other
Yeah.
things that Jupyter will kill you with. Um, we used to joke, I spent a number of years as a statistical consultant, and we used to say that 80% of any project that involves quantitative research is making sure that the data is correct so that your inferences are also. And that actually is probably the most important part, to have a workflow on that you can give new data and get clean data out of. Because it's also the place where a lot of the details will get lost. You end up with data that came in and is not like the other data. And I think that becomes more and more important as we are pulling in data, and we're doing kind of metadata almost, where we might be pulling data in from, we've got some data from NOAA, we've got some data from NASA, we have some data from the state of Colorado, we have some data from the state of Wyoming, and we're trying to come up with something that's mapping, air turbulence in the Rocky Mountains, and none of these data are exactly aligned with each other. So the process of getting that data so that it's homogeneous and the analysis will actually come out right could be the bulk. That could be 80% of the time you spend on the project. I've heard some really, really horrific stories from the people out at NCAR in Wyoming about atmospheric research and the various data sources and trying to get things lined up properly. So
100%. So, Scott, Hamshaw, your comments remind me of the workshop I did for DevCon last year. And I'm going to post a link to one piece of it. And so on this page, there's some really basic workflows, but I would encourage you to look at this Beard workflow on data visualization. And it really breaks things like what Scott was talking about into the different pieces, like acquiring the data, parsing it, filtering it, like all kind of the data manipulations that you go into, like the pre-processing of the data before you actually get to the visualization of the analysis. And I thought this was a really good way that Dr. Bird broke it down. And then there's a couple links in there to a talk or two that she gives and her book. And there's just one example of like a generic way to think of it. Obviously yours is going to be slightly different, but it kind of gets you through the steps, and there's a bunch of arrows to show that, like, yeah, you pre-process it one way, do the analysis, you realize that might have been the wrong way to pre-process it. You wanted a mode instead of a mean or some, silly thing like that. And you can go back and kind of restructure it in the way that you need to. But because you've kind of done it in a workflow already and thought about these pieces, it's usually much easier to go back and just make those little tweaks than having to like dig through pages of a script to find it.
Well, yeah, thanks for sharing that. I'll take a look at that. Yeah.
I think I find the other place where the workflows are worth their expense or worth their overhead is in the end game when you're trying to refine those visualizations, and it's like, oh, run it again and do this, or run it again and do that, or can you get this number out? And you're looking for just that nth little bit of extra information or that formatting. And if you can just hit you have this thing all set up as a workflow, and you can go and touch that data visualization module that you've written and just hit the do it button again and have it all just fall out the back end. If it's workflow built, you just go to the one place where all of the analysis is being done and the visualizations are being built, and it's just all right there. It makes it just quicker to turn it around again. So tomorrow I can have the new charts for you. It's not going to take me, I don't have to rewrite the whole script and find 20 different places where I generated 20 different charts. Just a thought.
Yeah, or I think that's like, or the folks that are doing the AI stuff, like you do all the data pre-processing and then you throw it at like say a LSTM to start, and then you're like, oh, that LSTM was cool, but what if I do like GCM? Is that another one, right? Help me out, folks. And so you can swap out the model for a different one. All the pre-processing is still the same. You just write a different function that feeds it to a different
Get that vector set.
yeah, that feeds it to a different a model. And so I think it's super useful for things like that, as well as you explore different options and different hyperparameters and stuff like that.
I,
So,
Yeah.
go ahead, Scott.
Oh,
I was
just
gonna
gonna
agree
mention,
with all that. Just with kind of what I have sometimes struggled with is like, because I like start setting up a workflow, then I want to try to put everything in it. And I myself find debugging workflows sometimes pretty challenging. And so I, sometimes or I think I, go against the maybe smarter path of like just stop the workflow like where like on maybe like all the prepped and pre-processed data, and then like do the modeling where you really need to be like a little more interactive and mess things up and move around. Don't try to like force that into a
Yeah,
workflow
yeah.
right away.
Workflows just definitely don't have to be run end to end all the time. You can just do the front third, and then sometimes I'll purposely throw an air condition just to derail it, just to stop everything. As if I wasn't smart enough to be able to just switch off the back end, I can make it crash.
Sure.
One,
Oh, go ahead. Sorry, Shari had something. I was curious what
Yeah.
he was going to say.
just real quick. I kind of learned over time that it would save me time if I just build these flowcharts, kind of like my pseudocode explanations before I actually start typing up code. It served two purposes. One, it was great if I needed to import this figure over into a publication down the line. It's easier to just modify the flowchart and make it publication ready. And secondly, I'm a visual person, so it helps me put together ideas and understand coding structure a bit better rather than trying to type up everything on the fly. So that's kind of how I've been systematically doing it for the past couple of years, and it's helped me out.
Yeah, great. Bennett, you were going to say something?
So one thing that sometimes gets overlooked, especially if there's a lot of data processing that's involved, is to think about how you're going to manage your record of what's been done and what hasn't been done, and building that into a workflow so that you've got a coherent track of which parts of the input data have been processed and which version of the software did the processing on them. I remember when I first got involved in helping people with running on the computing cluster, I had a guy who did a branch of commutative algebra, and part of what his program did was to look at groups and subgroups in mathematical terms. And until you actually started going down the path of figuring out how many subgroups there were, you didn't have any idea how many there were actually going to be. And we ended up with writing the algorithm to figure out how many groups there were was easy. Breaking it up into small enough sets of subgroups so that we could actually fit it into the wall time on the cluster was a good deal harder. And so what we ended up having to do was we spent probably half the time that summer writing programs to generate output so that we could generate more jobs that would generate more output. And we ended up with a 4-page paper that appeared in a letters journal, and we ended up with something like 11,000 output files. So, not just the stuff that goes in and gets done inside the code is always what you have to worry about. Sometimes it's also the records that you're keeping of what happened outside of it that there's also requires some management and some workflow and some thought. So
Yeah, I agree, Bennett. And oftentimes when it comes to that, a lot of the workflow management tools that are out there really help you with like the metadata and kind of the the history of the runs and the provenance of the where it's getting the code from and things like that. So that's when I mean, yeah, you can do that manually, but I tend to lean on some of the tools that kind of keep track of that for us because there's a lot to remember. A lot of that metadata is there's a lot to kind of wrangle. So, does anyone have a project that after kind of thinking about today that they want to apply this to?
So, hi, I'm actually working on big projects. Like I'm working on data from maybe 2 to 3,000 sites, and 2 to 3,000 sites mean I'm building a big pre-trained model from that data. And setting up that data is like a big mess. All of the time series, some of them has like 3 channels, some have 5 channels. Channels means like variables. Some have 15 minutes time gap, some has 5. So these are all the things I'm just thinking before building the model. I need a plan to make this data in one format so I can feed it to the model. Then like a format means like, for example, if I have no channels, like the total number of channels are 7 and I have 4 in one. So do I need to pad them, or I should change all the time series in a single sequence to just concatenate them to train this big pre-trained model? So there are all these things. So first, I believe, I agree with Scott that setting the data will give you the better idea what you want to do next. So nowadays, I mean, the coding of a model can be in thousands of ways, right? One model you can build in many ways, or you can come up with many different models. I think that's not the difficult part, but the data setting takes the most time, and I'm stuck in that. The memory crashes, it's a lot of problem, and then processing problems. So even our VACC only allow us to upload 1 GB of data. I have 80 GB of data. So I am very confused what to use. And I'm not sure if Cairo have any free resources for us to use their cloud computing for these kind of big models, because the VACC, I don't think it is gonna work in my case. So any thoughts on that?
Well, I don't want to derail this on your specific project, Ijaz, but you should email me and we can set up a chat and we can talk about it. Because yeah, I'm sure we can get it figured out.
Yeah, I mean, I just want to know if Cairo have any cloud servers for.
There is. So Cairo does have access to Amazon, and then there's like another GPU, or sorry, another HPC that they have set up. But I'm not sure that that's going to be the best route because um, uh, there's definitely a charge limit on Amazon, and if we spin up like a ton of stuff, that adds up pretty quickly. So there might be some better options.
Thank you.
Jazz, is that USGS site data that you're working with? Oh, you froze on me there for a minute. I was just curious, Ijaz, if you were trying to work with USGS site data from thousands of sites.
Was the question is for Ijaz?
Yeah, maybe that's okay.
Yeah, I can hear someone.
Oh, okay.
Yeah.
I was just curious if you were trying to work with, was it pulling USGS data for thousands of sites and processing that?
So actually, it was I think a few months ago we presented to USGS and a team of National Hydrology Canada team. These two teams, they were together, and Amber Jones, if you know her, she
Yep.
works in USGS. So she was like the host of the meeting. She wanted me to present the anomaly detection research, and then uh, I proposed an idea of making a big pre-trained model for some problems, right? And then they supported me with their data. So what I'm doing is that the hydrology department from Canada, they give me a few, like maybe thousands of sites. They give me from the whole Canada with their corrected data. And
Gotcha.
then the USGS, I got a link from Amber Jones, but to be honest, I went to StreamPulse, StreamPulse website,
Hmm.
Stream stats or
StreamPulse.
Stream Pulse. Oh yes, yes. Yep.
Yeah, if you go to StreamPulse, they have data from 750 sites from US, a little bit from different countries, but I'm just considering the US part from there. So I'm like that's available in a good format and easy to work on. So I'm trying to take that one in account. And if I needed like to balance between the hydrology data of Canada and the USA, then I may get some from the USGS side. But the issue is the Canadian data only has stage and discharge. And the rest of the stream pulse data has the 4, 5, 6 variables like different turbidity and DO and temperature, conductance and stuff like that. So these are also like things to understand if this big pre-trained model, for example, if it's trained in a way where we have more sites with just 2 variables and some sites and less sites in 4 or 5 variables there. So maybe it will unbalance things. So I'm just
Back in the
We
days
lost that.
before data science, we used to have
sorry,
to
my
deal with
internet
this.
my internet got frozen. Sorry. So yeah, but USGS data I'm using from StreamPulse. They also have USGS data, like 600-700 sites of data available. So that's easy to just get from there. And I know like it would be better if I can download a bulk from USGS, but I don't see a very easy option. I have to go I have to use some APIs maybe, but right? Is it?
Yeah, that's what I was just gonna quick, kind of if the like limit was, or if you were running into like trouble on sort of the data retrieval from tons of sites, we do have like some workflows both in R and I think in Python maybe too on, large data pools of stream flow and water quality data. I know we have like an example R workflow for doing that. So yeah, if Amber
Yeah,
might
you
be able
can
to
look
point
into
you in some
that,
of
yeah.
those too, but you're welcome to reach out if you have issues on the sort of data retrieval side.
Right, right. I will certainly look for that. I need to balance like the type of data I want to train my model with. So yeah, that will come in a week or two. I'm just trying to set it right now, the pre-processing step. Yeah.
Bennett, were you gonna say something?
I was going to say back in the day before data science was invented, we statisticians had to deal with how do you handle missing data. And I was just kind of curious. I haven't been around at any rate if there have been discussions about how missing data has an impact on machine learning, especially if you're training models. Like if you're training a model and you have access to a lot more data than the data that your model is then supposed to be deciding on, what kind of an impact does that have on the accuracy of your predictions? Um, in classical statistics, if you've got large sample sizes or external data, you can often come up with data imputation methods that can help to fill in some of those things. It didn't sound like your problem with the Canadian data versus the US data was like that, but so back to you, HS.
Yeah, so imputation, yeah, like the project I'm working on, this pre-trained model will be serving three purposes. It will be doing forecasting, it will be doing imputation, and it will be doing anomaly detection. And the point is, I'm first training it on a correct data, like I'm looking for corrected data, the QC data, not the raw one. So I have collected the QC data for now, which has no gaps in there. So my model learned all the correct patterns, everything, right? And then the pre-training will be done in a way like we do for these big GPTs, in which we mask some, we keep masking the data from the model, and then the model try to learn how to fill in the blanks. So when the model learns how to fill in the blanks, these kind of models can be used for imputation very well. And I mean, I'm following some papers from top note journals and conferences, and some general purpose time series big models are doing this very well. So I assume, like, this is my assumption so far, that like now people are working to build this big huge model to solve all these problems which we used to solve using one static model, right? Small model. But now, like, for example, if the thing I'm building, it will be helping mostly in the correction of data, anomaly detection, imputation, correction. So when that will be done, then our models will have better data to work on. So, of course, imputation is always a problem, the way in which we fill our data. If there are long gaps, the interpolation doesn't work, the small methods doesn't work. If their gaps are small, then we can just use some small techniques. In one case, when I was working on a model, and there was a data from one side which was missing a lot, then we were thinking of how to fill that gaps. So we were looking for the sensors nearby, the nearby sensors. For example, I have a temperature here and a temperature in a kilometer and another in 0.5, like mile or something. So we get we try to find the relations between these variables from the previous data and try to predict the gaps from the nearby other sensors. So there can be like many ways, not just those simple interpolation or fill forward or backward, but uh, yeah, like we can think of if we have like if we are dealing with sensor data. In my case, I'm working mostly, so we always come up with such ways to get the gaps filled using other nearby sensors from the area. So yeah, many things. Science is good.
Not to turn this into like a data processing discussion, but I think that missing data is important. Also, just like if you are setting up a workflow to like pull in data, just like, be aware of if that tool or data source is doing any like filling of missing data itself. And like, if there is like how that missing data is handled, even pulling like USGS daily streamflow, like I think some people miss that by default you're getting a mix of observations from that station and estimates that were, filled from other nearby stations, and you can filter out those like estimated data if you want, but by default, you're getting essentially gap filled time series.
I mean, gathering data from foreign sources isn't workflow in itself. Right?
Yeah.
It's not. So we're doing ourselves a disservice if we stop it and think about this only in the analytic code that we're writing. And cleaning, all of the data cleaning and data processing is, like I said, that's a huge workflow problem, and there's a lot of programming that goes into it. I've worked with a lot with MRI and EEG data, and we have to worry about, there are sporadic signal spikes because of the equipment and electromagnetic variation and so on and so forth. How do you determine whether that's a legitimate spike because somebody really had a reaction, or whether that's just an accidental spike because they moved? And similar with, sensor data. If you've got your sensors all at the same elevation around a valley and you're looking at winter temperatures and you don't have sensors in the floor of the valley, you're never going to pick out that the microclimate of the floor of the valley is 15 degrees colder than it is halfway up the slope. So, there's all kinds of places where weird stuff can happen. We used to run into that. I spent some time with a friend of mine up in Fairbanks, Alaska in the winter. And Fairbanks sits in a valley, and he lived up on the slope, and it was always warm up on the slope. And then we drive down into town. It was like, oh my God, I didn't wear enough clothes. And they even have pollution standards are different in the winter because automobile exhaust, right? It sits in the valley and it's got all that heavy cold air, and it just keeps it in the valley until the thaw. And so they don't care whether you run your summer car in the summertime because the air's getting cleaned out, but they want you to have really good smog control if you're going to drive in the winter. So.
Well, team, we're coming up on time, so I'm gonna. Any last quick comments on the workflows? All right, I'm gonna stop recording. So.